Now we will learn how to write the main VHDL model and test bench VHDL model for 8:1 multiplexer with active low enable. So we will follow this particular block diagram. As we see here, the multiplexer is having one active low enable signal En. The 8 inputs denoted by the vector I, that is I parenthesis 0 to I parenthesis 7. It has a 3-bit select line bus S, that is S parenthesis 2 is the MSB and S parenthesis 0 is the LSB. It has one output Y. And we can see the truth table for select line combinations from 000 to 111. The inputs I parenthesis 0 to I parenthesis 7 are sent to the output Y. Now we will start creating the MVMs and TVMs in Xilinx ISA. File, new project. We can give the name as mux using enable, Control A, Control C, next, next, finish. Keeping the tool in implementation mode, go to target line, right click, new source, VHDL module, paste it, reselect, next, change the architecture name to entity name underscore ARCH. As per the block diagram, inputs are En, which is 1 bit, I is 8-bit input, S is 3-bit input, and Y is 1-bit output. So En, I, direction is in, we can select bus, we can say 0 and 7. Select line S, input, bus, 2, 0, output Y. Delete the comments. Now the first modification which we have to make is, we have to change line number 8, which defines the signal I as an input and a 8-bit vector, but writing 0 down to 7 is not acceptable in the language. We have to write 0 to 7. Then we are going to use behavioral modeling style. So using the process keyword, parenthesis, the sensitivity list, that is all input signals separated by commas, En, comma I, comma S. Close the parenthesis, process begin. We will write now in the truth table we have not shown the effect of En, but we can understand that because it is a multiplexer with active low enable, this system will act as a multiplexer, that is this truth table, provided En is equal to 0. For En equal to 1, the multiplexer should be disabled, for which we can assign a high impedance state to the output Y. We will say if En equal to single quotes 1, then that is disable state, output Y is assigned single tick Z semicolon. Else we can write a case statement here. Case S is when double quotes 000, then Y is assigned I parenthesis 0 semicolon. We can copy this statement and paste it 7 more times. 1, 2, 3, 4, 5, 6, 8. Close the case construct. Close the if construct. Close the process construct. Now as per the truth table, we have to make the changes. 0, 0, 0, 0, 0, 1. 0, 1, 0. I2 is assigned. 0, 1, 1. I3 is assigned. 1, 0, 0. I4 is assigned. 1, 0, 1. I5 is assigned. 0, 1, 2, 3, 4, 5, 6. I6 is assigned. And for I7 to be assigned to Y, we have to write when others. Okay, that means the last statement is redundant. 1, 2, 3, 4, 5, 6, 7, 8. Okay, delete. Save, select the MVM. So we have to define the signal Y as output. So synthesis has been successfully completed, that is without errors and warnings. View RTL schematic, double click. We have the multiplexer here. This is the technology schematic. This is RTL schematic, sorry. View technology schematic, double click. Yes. So now we move on to the next step, that is simulation of test bench VHDL model TVM. Change the tool from implementation to simulation mode. Select target line, right click and say new source, VHDL test bench. Select, copy, paste, underscore TB, reselect, next, next, finish. Close the schematics. Delete the comments. You can delete the clock period definitions. Also delete the clock generation process. And now we have to write a process for changing the select line from 000 to 111. So we will delete this statement from the ready-made process. Give the name stemproc s, indicating we are writing it for select line, we can simply say select line S is assigned S plus 1 semicolon. We can say wait for 10 nanoseconds, and to have compatibility between the integer 1 being added to the signal S belonging to standard underscore logic data type, we will add one library statement here. Use IEEE dot std underscore logic underscore unsigned dot all. Okay, and here we have to write one more process for enable. So copy, paste, change the label to en to indicate to us that we are writing a process for enable. Here we will have our enable wait at 0 for first 80 nanoseconds. So enable is 0, so system is enabled. We will say wait for 100 nanoseconds, then en is assigned 1. We can say wait for 30 nanoseconds, then again en is made 0, that is mux is enabled, and we can say wait for infinity. So as per this process, the enable signal will remain 0 from 0 to 100 nanoseconds. It will become 1 at 100 nanoseconds and continue at 1 till 130 nanoseconds. At 130 nanoseconds, it will become 0 and it will remain at 0 till infinity. Now here what we will do is, instead of I being initialized to all zeros, we'll initialize it to 1010 1010. So we will just write double quotes 1010 1010 double quotes. Another simpler way of writing is using bit string literals. So 1010 1010 in hex form is AA. So we will write capital X and A and A. So when this test bench will be simulated, at that time the tool will convert the characters AA to 1010 1010, and we will also initialize the select line S to 111 instead of 000. Doc simulation mode, expand, select the TVM, select the process and say behavioral check syntax. Float. Okay. So we can see here that the enable signal is equal to 0 from 0 nanoseconds till 100 nanoseconds. So from 0 to 100 nanoseconds, En being 0, multiplexer is enabled and it is sending the inputs I0 to I7 every 10 nanoseconds when select line changes from 000 to 111. So we can see here that when select lines go from 000 to 111, that is from 0 to 80 nanoseconds, our inputs are sent. So we are having wires 1 0 1 0 1 0 1 0. At 100 nanoseconds, we can see here enable signal is becoming 1 and is remaining at 1 till 130 nanoseconds. So from 100 nanoseconds to 130 nanoseconds, En equal to 1, multiplexer is disabled, And as per our logic written, we are seeing here that the signal Y is remaining equal to Z from 100 nanoseconds to 130 nanoseconds. From 130 nanoseconds till infinity, En is equal to 0. Multiplexer becomes enabled. We can see here that the outputs are actually following the inputs I0 to I7 as and when the select lines are changing from 000 to 111. Thank you very much.